Hello, Precalculus. So we just wrapped up chapter 11 on exponential and logarithmic stuff, and with that we're dealing with continuous things, right? So it's like you have an infinite number of x values between 0 and 1, and it's a continuous graph when you're dealing with the exponential and logarithmic graphs. What we're getting into next is a new unit that is discrete math. And discrete math involves things that come at like distinct values. Another way of describing it is the values that you're dealing with are countable. And this has three units. There's chapter 12, or sorry, three chapters. There's chapter 12 that has 9 lessons on sequences and series. And then there's chapter 13 that has 6 lessons on probability and odds. And then chapter 14 has 5 lessons on statistics and data analysis. And then after that, we have one more chapter that is the last chapter of the book. It's the more directly dealing with you getting your feet wet with calculus, of learning about derivatives and integrals. And that one is 4 lessons. So yeah, I think I mentioned earlier in the year, this fourth quarter stuff, traditionally, students on average do much better in the fourth quarter material than than all of the other quarters of the year. First quarter is usually second best, and then second or third is kind of a mixed bag, but usually fourth quarter is the best quarter grade-wise for students. So, chapter 12, this is lesson 12.1. It's called Arithmetic, Sequences and Series. Let me start to get this down. So, let's see. Let me grab my black here. So, this is 12.1, Arithmetic. It looks like arithmetic, but if you're using it as a noun, you pronounce it arithmetic. If you're using it as an adjective, you pronounce it arithmetic. Arithmetic sequences. Oops, sorry, accidentally scrolled. That's what happens when I'm too close to the top. Sequences and series. So this does kind of raise the question, what's a sequence versus a series? Well, we can go ahead and define those real quick. A sequence is just a list of values. Whereas a series is the sum of the elements. Sum of the elements of a sequence. So we could say that, like a sequence, we could say might be something like the set where we have A1 is the first element of that comma, A2, comma, A3, comma, A4. So this would be a sequence that has 4 values in it. And then a series we could describe as like S sub n, where the S is kind of like the sum, and then n is like the first n elements of a sequence. And actually, I'm going to erase this n bracket here and say comma, dot, 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 comma, a sub n to make this not a 4-valued sequence, but an n-valued sequence. So, if n is 12, then you have 12 items in the sequence. So in the series, S sub n, the sum of the first n items would be a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus dot, dot, dot plus a sub n. And when you use dot, dot, dot like that, what you do is whatever operation you're doing, you include it at the beginning and at the end. So that's why I did a sub 4 plus dot, dot, dot plus a sub n. All right, so that's the difference between a sequence and a series. Now, what makes a sequence or series arithmetic is that there's a common difference from one term to the next. So arithmetic, we could say is like this. A sub 1, all right, that's our starting value. Then how do you get a sub 2? Well, we could say that a sub 2 is a sub 1 plus d, whatever that difference is. And then, all right, well, what would be a sub 3? A sub 3 is you add d again. So that would be a sub 1 plus 2d. And then how do you get a sub 4? Well, you add d again. So that's a sub 1 plus 3d. So this kind of yields a formula for the nth term of an arithmetic sequence. The nth term, a sub n, is a sub 1 plus n minus 1, because notice for the second term we added d once, for the third term we added d twice, for the fourth term we added d 3 times. So the number of times you add d is one less than which term you're on. So if we're on the fourth term, we're adding d 3 times. So the nth term that we're after here, we're going to add d n minus 1 times. So n minus 1 times d. That'll give us the nth term. So, and kind of implied in here, though I haven't explicitly said, this one way to test if an arithmetic sequence is arithmetic is do like the third term minus the second to see what the difference is. Then do the fourth term minus the third to see what the difference is. Do the eighth term minus the seventh to see what the difference is. And if the sequence is arithmetic, then the difference will be the same every time. All right, so an example here would be like find the, I don't know, 24th term of, and let's go 5, 8, 11, dot, dot, dot. Okay, so let's see what we know. Well, we know a sub 1. We know that the first term here is 5. What else do we know? We can find what the common difference is. The difference between the first and second term and the second and third term, the difference each time is 3. So that gives us what we need to know to find the 24th term. So we would use the formula. So we're finding a sub n equals a sub 1 plus n minus 1d. So if we plugged in everything, we're finding the 24th term. So rather than a sub n, we're going to say it's a sub 24 equals a sub 1. Well, that was 5 plus 24 minus 1 times 3. I'm showing a little bit more work than you would have to. You could, rather than starting out writing the formula, you could, although I usually recommend start out writing the formula. That way, every time you do the problem, you're reminding yourself, this is the formula, and you're like memorizing the formula every time you do a problem. Start out writing the formula, but then like here, you wouldn't have to write, 24 minus 1. You could just write that as 23 kind of stuff. Anyway, so what do we have here then? We have, blue. So 23 times 3 is 69. We're going to add 5, so 74. So 74 would be the 24th term of that sequence. Okay? All right. So then we can deal with finding the sum of the first n terms. So continuing our notes here, this would be another formula. We could write s sub n. Well, here's what's going on. The way the pattern works is if you could find the average between the first term and last term, okay, and then multiply that average by how many terms there are, you would find the sum of all of them. And that's what's going on with the formula. So I prefer to write the formula slightly differently from how the textbook gives it, because I think it communicates the idea of what's going on better. So how would you find the average of the first and last term? Well, that would be a sub 1 plus a sub n, a sub 1 the first term, a sub n the last term, over 2, right? Because you're finding the average of two things. Then if you take that and you multiply it by the number of terms, you would get the sum of the first n terms. That's what's going on here. And there's some story about, oh, I'm suddenly drawing a blank. I was about to say Rene Descartes, but it might have been a different mathematician. I don't remember right now. Euler. I think it was Euler. When he was in, like fourth grade or something like that, he was kind of being slightly disruptive because he was finding the classwork a bit too easy for him and kind of boring. And so his teacher figured, I'll keep him busy for a while. It's like, hey, you, all right, here's what I want you to do. I want you to add up, do like 1 plus 2 plus 3 plus 4, add up all of the numbers from 1 to 100. And the teachers kind of think this will keep him busy for a while. It's like, don't say anything until you have the answer. So Euler, if it was Euler, I need to double check. Sat there for like just a few seconds and then gave the answer. And the teacher's like, what? And well, he did it this way. What he did is he's like, okay, well, let's see, 1 to 100, and he just kind of deduced on his own. He didn't know this formula. He just deduced this property on his own. He's like, well, let's see, 1 plus 100. If I found the average of those, well, 1 plus 100 is 101 divided by 2. That is 50.5. And if I multiply that by the number of items that I'm dealing with, so 50.5 times 100, 505. And he just like pulled the answer right off the top of his head like that. Okay, I'm going to hold off on using this formula until, well, we do 1 or 2 more examples. Because sometimes what happens is, notice in order to use this formula, you need the first term. You need to know what the first term is. And you need to know what the last term is, obviously, and the number of terms, okay? So sometimes what happens is you might not know what the last term is in order to plug into this formula. So sometimes what you need to do is you need to use this formula, to find what the nth term is. Then once you know the nth term, you can combine that with the other pieces of information that you have in order to find what the sum of the first n terms is. And the sum of the first n terms are. So, for example, let's go ahead and jump into an example here. So that would be like, example, how would we do? We just build on what we had. No, I'll do something different. Find the sum of the first 17 terms of 4 plus 9 plus 14. Nah, I want to go with a different difference there. Let's go 4 plus 8 plus 12 plus ... Okay. So if we want to find the sum, what piece of information do we need to know? We need to know how many terms there are, what the first term is, and what the last term is. So we know what the first term is. It's 4. We know how many terms there are. There are 17. We need to find what the last term is. So let's go ahead and first we need to find, oops, I accidentally erased too many things there. Let me go back. So this was in our formula a sub n. So first we need to find a sub n. In this case, what are we finding? We're finding a sub 17. So we know a sub 17 equals 4, the first term, plus, if we're finding the 17th term, we're going to use 16 times the common difference. What's the common difference here? It's 4. So we do this, so we have 16 times 4 plus 4, or 4 plus 16 times 4. So the 17th term is 68. Okay. Now we can use our sum formula to say S sub n equals a sub 1 plus a sub n over 2 times n. So that is 4 plus 68 over 2 times 17, because we're finding the sum of the first 17 terms. And 4 plus 68 is 72, divided by 2 is 36, times 17 is 612. So there we go. And then one other thing that comes up in this is something called arithmetic means. I had an example of one like that. Arithmetic means would be like in between terms that complete the pattern. So that one's a little uglier than what I want. I'll tell you what, we'll just make one up. So it might be something like this. I want black. Keep things consistent. Example, write a sequence that has, let's go 2 arithmetic means between 11 and 54. I just pulled 2 numbers off the top of my head there. So in other words, what we want is we want a sequence that looks like this. We want a sequence that goes 2, comma, blank, comma, blank, comma, 54. That's what we want. All right. So what do we know? Well, we know that this is a sub 1, and we know that this is a sub 1, 2, 3, 4. This is a sub 4. So what do we not know? We do not know what the difference is, but we can use our formula for the nth term in order to find the difference. In other words, we can use a sub n equals a sub 1 plus n minus 1 times d to solve for d, because we know every other piece of information. Because we know a sub n is 54, we know a sub 1 is 2, and we know n minus 1 is 3, because we're dealing with the 4th term. So we can use this information to find d. So subtract 2 from both sides, we get, 52. Got a little crossed up with what I was writing there. We can say 52 equals 3d, and then solve for d, and what do we get? I'm just going to go with d as 52 thirds, because I don't think that reduces at all. 52 thirds, nope. So d is 52 thirds. So it's going to be ugly, but we can fill in the gaps here by saying 2, and then so what's the next term? The next term is 2 plus d, 2 plus 52 thirds. So if we go 2 plus 52 thirds, that's 58 thirds. 58 thirds, which I'm going to get rid of that blank because that might look confusing. 58 thirds is the same thing as 19 and 1/3. 19 and 1/3. And then we need to add another 6 thirds, so 58, 59, 60, 61, 62, 63, 64. So we're at 64 thirds next, which 64 thirds, so if we're at 19, 20, 21 and 1/3. No, 21 and 2/3. No, 21 and 1/3. Oh, no, I'm not adding 2. I'm sorry. Ignore what I just said. For some reason, I said, oh, 58 thirds plus another 2/3. Like, no, we need to add another 52 thirds. So that is, what, 110 thirds. 110 thirds. Oops. Bloop. Does that make sense? So I did 2 plus the 52 thirds to get 58 thirds, and I needed to add 52 thirds. 58 plus 52 is 110, so I'm at 110 thirds. And that is 36 and 2/3. And then if we add another 52/3, we get to exactly 54. So my two answers here, these are my answers. These are the two arithmetic means between 2 and 54. Okay? That is lesson 1. Should get you well set up. But as always, feel free to shoot me an email or hop on to one of my office hours if you have any questions. All right. Hope you're doing well. Bye.